Hi, Assalamualaikum. Today I'm presenting the experiment 5, which is about frictional force. These are my group members. You have Faris Faik, Aiza Farina Elisa, Nick Nur Batrisha, Nur Aina Hasha, Nur Adelina Atira, and me, Izzama Fuzahanim. The objective for this experiment is to determine the coefficient of static friction of different surfaces. Here are the apparatus that we are used for this experiment. We have string, tabletop, wooden block, 10 of 50 gram masses each, and 10 Newton spring scale. First step, you have to measure the mass of the wooden block and record it. Then, set up the apparatus. You have to make sure the tabletop is stable and horizontal to the ground. Next, you have to attach the spring scale and the wooden block with a string. Place them horizontally on the tabletop. You have to make sure the rubber side of the block was faced downward. Then, place a 50 gram mass on the wooden blocks. Next, pull the spring slowly. When the blocks start to move, record the spring scale's reading. You have to repeat this step 4 until 5 as trials. Next, you have to add another 50 gram mass on the wooden block and repeat steps 5 to 6. You have to repeat these steps for 10 times. You have to repeat steps 1 until 8, but this time the rubber side of the wooden block was facing upward, and record all the data. Here are the results for rubber surface towards the floor, and this for non-rubber surface towards the floor. Here are the analysis of this experiment. First, draw and label the free body diagram of the wooden block. Second is plot graph of static friction force against normal force. You have to plot two graphs, which is the rubber surface and non-rubber surface. Use the gradients obtained from the graph to calculate the coefficient of static friction for each surface. So, we get 1.18 Newton for rubber surface, and for non-rubber surface is 0.41 Newton. Lastly, we have to compare and discuss the coefficient of static friction. So, the coefficient of static friction for rubber surface is greater than non-rubber surface towards the floor. This is because the high internal friction exhibited by rubber over a wide frequency region.
Next, we move to question number 1. How can anti-lock brakes stop a car in a shorter distance than regular brakes? The answer is, anti-lock brakes use ABS to prevent wheels from locking and skidding even on slippery surface. At the same time, the regular brake will lock up the wheels and make the vehicle, so that ABS can stop a car faster than without ABS. Therefore, ABS provides a shorter distance than regular brakes. Move to question 2. From your experiment, which material has the highest coefficient of static friction? Let's disagree with your hypothesis. What do you think determine the coefficient of static friction? From our experiment, the material that has the highest coefficient of static friction is the wooden block on the rubber side. And yes, the hypothesis was agreed upon. The coefficient of static friction is determined by the nature of the materials in contact, surface roughness, and the presence of any intervening substance. It essentially represents the amount of force needed to initiate motion between the surface when they are at rest. Move to question 3. Once the mass begins to slide, does it move smoothly, or does it undergo stop and go motion? Explain the motion. Once the mass begins to slide, the mass undergoes stop and go motion because the mass does affect sliding friction. The greater the mass of an object, the greater the force. The greater force has more friction between that object and the surface it makes contact with. The force of friction opposed the motion of an object, causing moving objects to lose energy and slow down. Therefore, the gravity force also will affect the movement. Furthermore, the discussion from the experiment, free body diagram of the wooden block can be drawn. Next, the graph of static friction for rubber surface and non-rubber surface toward the floor was plotted. From the graph, the static friction force is proportional to the normal force. From the calculation carried out using that formula, the value of coefficient of static friction force for rubber surface was obtained from the gradient, which is 1.18 n, while for the non-rubber surface 0.41 n. Last but not least, the coefficient of static friction for the rubber surface is greater than the non-rubber surface toward the floor. This is because of the high internal friction exhibited by rubber over a wide frequency region, so the experiment is successful. And lastly, conclusion. We have successfully performed the experiment. The coefficient of static friction of different surfaces were determined. The coefficient of static friction for the rubber surface is 1.18 n, while for the non-rubber surface is 0.41 n. Thank you everyone. Have a good day. Bye bye.